Lamplight Acres, a residential development in Williston, Vermont, suffers from flooded and icy road conditions during the spring. Even though the soil in Lamplight Acres is well draining, during winter the high water table freezes and ice fills the pore spaces. When the snow melts in spring, the frozen soil doesn't permit drainage. As a result, snowmelt will form ponds on top of the soil in the low-lying roads. Subsequent freeze-thaw cycling not only causes damage to the roads, but also creates conditions that are dangerous for drivers and pedestrians alike.
Before any design work could commence, it was necessary to accurately characterize a study area through a series of field and laboratory tests. We began by taking 3 soil samples to provide a general description of the soil characteristics of Lamplight Acres. These samples were brought to the lab where hydraulic conductivity, sieve analysis, and moisture content tests were performed. Based on the lab analysis, the soil was classified as silty sand. Additionally, infiltration tests were performed in the field to quantify the drainage capability of the existing soils. These infiltration tests confirm that the soils fall under the NCRS soil classification of hydrologic group A, meaning high infiltration rates and low runoff potential. The data obtained from soil analysis allowed us to create a HydroCAD model to replicate the stormwater runoff characteristics of Lamplight Acres. CN numbers were determined for each drainage area based on the moisture content and soil type of each area. Using these CN numbers, the predicted runoff volumes for a 2-year, 24-hour storm was determined. This volume allowed us to calculate the necessary rain garden dimensions for each catchment area. 3 water samples were also taken from separate ponding locations on the streets of Lamplight Acres. The samples were then tested in the lab for phosphorus content. Although the results showed a relatively low phosphorus content, it should be noted that the phosphorus concentration of the puddles was twice as high as that of Allen Brook, the nearest waterway.
To design the trenches and rain gardens, we first needed to decide what materials to use. Following the Vermont Stormwater Manual, a top layer of mulch will be necessary to surround the base of the plants. The plants and the mulch are the only difference in the design of the rain gardens versus the trenches. Below the mulch will be a layer of topsoil. We then chose to add a 2-foot layer of sand below the topsoil. With an infiltration rate of 3.5 feet per day, the sand will quickly absorb inflowing water. Below the sand, separated by a geotextile filter fabric, is a layer of gravel. This will add a great deal of void space to the overall design, which is key for larger storm events. The fabric will also run along the side of the entire trench so that a layer of gravel can span down the entire depth of the installation. This will allow for water to infiltrate the trench even when the sand and topsoil are frozen. Lastly, a perforated pipe will lay within the base gravel, which will also create additional void space. The option of whether it will be a trench or rain garden installed on a property is up to the individual homeowner. Therefore, 3 alternatives were designed for the neighborhood. The first planned for 100% of the installations being rain gardens, the second for 100% trenches, and the third a 30-70 split of rain gardens and trenches respectively. Based on input from our community partner and Lamplight Acres residents, we believe that alternative 3 will most accurately represent the preferences of the community. Once the materials were chosen, a cross-sectional area was used to calculate the total void space of the combined materials. The total runoff volume for each zone was then divided by the area of the void space of a trench or rain garden to then give the total necessary length of the installations in each zone. With all the necessary total lengths of the gardens and trenches to be installed in each zone, we then were able to position the gardens and trenches in areas where they would be most effective. As of now, our cost analysis is based solely on the cost of materials. The total costs for each alternative were based on the length of installations for each option.
All plants chosen are aesthetically pleasing, native to Vermont, and are perennials. Some plants, like the broadleaf arrowhead, are great at absorbing excess nutrients. The placement of the plants within the rain garden are based on how they do in different depths of flooding.
The Vermont Stormwater Management Manual is the governing legislative document for stormwater mitigation projects in Chittenden County, where the Lamplight Acres study area is located. All regulatory guidelines from this manual were closely followed to determine the necessary dimensions of rain gardens and trenches. Additionally, all criteria under the Land Use and Development Act, also known as Act 250, applies to the Lamplight Acres development. To comply with the existing Vermont Act 250 jurisdiction that is attached to the Lamplight Acres development, stormwater, soil erosion, and other criteria were followed in the design process. There were no federal permits that needed to be obtained for this project. For state permits, the town of Williston has an existing NPDES general permit for stormwater discharge, also known as the MS4 or Municipal Separate Storm Sewer Systems Permit. Additionally, the need for an underground injection control permit for stormwater was investigated but deemed unnecessary due to the lack of injection wells in the study area. In terms of local permits, basic construction general permit will be obtained after final engineering plans have been approved. Because these rain gardens will be constructed in the town right-of-way, A permit to open streets or right-of-way was acquired and will be filled out and filed before construction begins.
With our rain gardens and trench designs, we will address these issues so residents don't have to pay for flooding or worry about harmful conditions in the future.